Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. My name is Rodrigo here at The Construct, and today we have a presentation for ROS 2 Basics in C++. Correct me if I'm wrong, Lou, but welcome, Lou.
Yep. Thank you.
How are you doing? We've seen you once before.
Yeah, yeah.
Great.
Good to I'm happy to come back.
Well, we're
I
happy
may
to.
come back more.
Yes, we're happy to have you here again too, so you can now explain your project for the course you took on ROS 2 Basics for C++. So I'll leave the floor up to you. Whenever you want, you can start sharing your screen so we can
Okay,
take a look at the work you've done.
sure. Okay, let me start share my screen. And this one share. Can you see my screen now?
Yes, we can see it.
Okay, so I suggest we just do the similar thing like last time. We let it run first, so
Let's run
you
it.
see it
Yes.
how it works, and then we go to the code and look at it every part of software in detail.
Yes.
So and here I'm connecting to the real robot in the lab, and
Mm-hmm.
before I have moved this robot to some random location. And also you see the direction orientation is also random, facing like
An
object here.
obstacle. Mm-hmm.
So hopefully the robot will rotate to run to the nearest wall and start. So
Yeah,
just
that's
again remind everybody this is kind of two part of software. One part is look for the wall, go to the nearest wall, and second part is start the odometry record, and at the same time start the following war process, and this thing will follow war in four wars and come back to the original point. That's when everything stopped and
great.
there. So let me launch the software. Hold on, give me a second. Okay, now I'm going to launch, and it's going to
By the way,
check.
while this is going on, I'm sorry. I said ROS 2. This is ROS 1.
ROS 1. I'm sorry. Yeah,
Yeah,
it's
yeah.
ROS 1. Yeah,
I'm sorry. I
no
misspoke.
worry.
This is ROS 1 in C++. Great.
Yeah, yeah, that's right.
So right
Okay,
now,
now it's facing the wall, and you see when the index number around 360, that's when it's facing the wall, and it will start to move toward
uh-huh.
toward the wall. So yeah, it's coming,
There we go.
and it will turn this off. Left turn, and once finished left turn, it will surface finished. Then we'll start to action and follow the wall process. And here you can see what I show on the terminal is the distance from the wall, and hopefully we keep it between 0.2 and 0.3 meter. And also once a while you can see they
Hello? I think I lost him. Let me see if it's me. Hello, Lou?
or something. So
Oh,
also
there you
this
are.
numbers keep going. Yeah,
I'm
numbers
sorry.
keep
We
going.
missed you for a little bit. You froze.
Okay, I
So
see.
sorry.
Yeah.
Sorry if I was. Uh, I don't know if it's me or you, but keep going, please. I'm sorry.
Okay. Okay. Can you still see me?
Yes, we can see that the robot's still moving. The terminal is not. You keep freezing, so.
Hmm. I don't know. Is it because my Wi-Fi? I mean, I can see my terminal still moving, and also um
There we
the
go. There we
okay.
go.
Yeah.
It's. I mean,
Okay.
we see the robot move, but the.
Yeah.
Oh, there you go.
Okay.
Now you switched. Okay, it's coming back. It's coming back.
Yeah, on my side, I see one of the camera kind of freezed for some time. Now everything's back now. So,
Yes, this might be
uh,
our internet actually. So I don't know. But okay, we see it go around
yeah, and
and
okay, yeah, it's end. Now I'm at terminal end, and yeah, everything back here.
all
Now it
right, but
stopped.
we were able to appreciate that the robot found the wall and then went around kind
Mm.
of halfway. Like you got froze and then it arrived. So
Oh,
we understood the whole thing. So
okay,
great. We can see that
okay,
the action has been completed, which is the
yep,
third section. So
yep.
if you want, you can just go into the
Uh,
actual code
okay,
because I see
sure.
a lot of them. I mean, maybe I'm misremembering, but this looks like a little bit more smoother, a little nicer,
Huh, really?
and
Okay,
especially for the first part, I
I
remember
see.
that the obstacle was creating a little bit of an issue last time, but now we saw that it was
Yeah,
facing the obstacle and it went. So I'm excited to see what you've done there.
yeah, okay. Yeah, I think the fine wall surface, which is the we detect obstacle. That particle is a little bit complicated, so I my plan to leave it to the end
Great,
in case we run out of time. So I would just go through step by step to start everything piece by piece.
great.
So can you see my code now?
Yes, we can see it.
Okay. All right. So let me start here. So there's this software, this piece of software we're looking at right now, this is kind of the main, I don't know if we should look at the launch. So the launch basically launch three pieces, launch three softwares. One is the surface server,
Uh
the
huh.
fine word surface server. Second one is the action server, the odometry record action server. And those two we'll talk a little bit later. And this one is the last one. This is including the follow the wall process
Mm-hmm.
and two client to work with the two servers we talked earlier. So this is kind of the main um, software. So we can start from here and follow your suggestion. Actually, I put kind of every process into classes. So
Yeah, I can see that. I
so
can
I
see
have one.
libraries, which is awesome.
Yeah, yeah, so this is I put them into the header file. So so you can see one of the header file is action client and find war surface client
Mm-hmm.
and the follow war which is the follow war process. So
That's awesome.
I put each one into class and put into the header file, which we'll talk in a minute. And so the main is relatively simple. So which is start
Yeah.
a node and create a find wall surface client and start the surface. So that's when we see the robot turn around, run to the wall, and then make a left turn. And after that, uh-huh, and as remind. So this surface is not what do you mean? It is the software will wait here until the surface finish. And
Okay.
then we come to the next one. We create a autumn record action client, and then we call, we start, which is we call the server, and at the same time we also create a follow wall object, which is also we started, and follow wall we have an update rate of 10 hertz, and we every which means every 0.1 second we draw one step and we spin once, which is the time we get all the scan subscription scan record read, so to direct the robot, and we kind of sleep a little, wait a little bit time. So that's
Mm.
what happened. And what last piece is for this action I have another method, which is return the action done. So whenever the action done, which is automatic record, will see if the robot have come back to the original point. Once it's get there, this action done will become true,
Right.
and which is make this force and get out this while, and then we stop the robot and get out. So
Right.
that's
Yeah.
the main.
I love this. Very simple, and I love that you don't have any code here. You're just taking it from somewhere else. That's great.
Yep, yep. So let's go from start from easy one. So which is a follow war, which is I put a whole class
Uh-huh.
in this header file. So so you can see to start with, I claim some variables used by the class. This is front and right. I make the name simple. Actually, this is the front. I use it to indicate the distance from the front. So which means, the in front of the robot, how far there is the wall
I
or any
understand.
object. So that's what's restored. And the right, same thing, the right distance. So that's right now I give you a very large number. Hopefully it get updated later. So
Okay.
the shortest index is similar to what I had, for the Pythons. This is indicate when I find the shortest distance, which index, which means which direction of from which direction of the robot we see the shortest distance. By the way, I don't know if I should remind. So for this scan, laser scan result message, and for this robot, we see index, which is all the messages. Oh, I mean the data inside the message. Index go from 0 to 720.
Yeah,
To,
720.
to be more specific, 3719. And so so 360 degree around robot. So 0 and the 720 is way at the straight behind the robot.
Yeah, it's
And
usually
then
like that in most robots.
yeah.
So
Yeah. And then I go to the right side with index increase until go to the front, which the index is 360. That's where in front robot. So I just remind everybody in case you are not you're not super familiar or forgot about this.
yeah, yeah.
So here is an have received a message. I have put in there node handle and publisher. This publisher used for publish the command to drive the robot, and then I have ROS subscriber to subscribe um, the scan result, and we have a callback function defined here. So so again, you can see its constructor is pretty much simple default kind of, and then we may go to maybe the scan callback first. When we look at scan callback, you can see when I give this a scan receipt as a true. So hey, I have received the message. So you see we'll use that later. And then the front, as we just talked, in the distance from the front to the nearest object, it's index as 360. So we see from front how far from
Why do you
object.
add that scan received again? Was there any problem? What made you
Yeah,
decide that?
yeah, good point. When I do my test, I can't guarantee. Let me think. Yeah, I can't guarantee which one start first, and I suspect if there's is a case, I haven't received any scan message, but I start driving. That's
Ah,
something I don't want. So what you can see here is in the drive process,
if that's
I
perfect.
always check this. If
That
I
answers
haven't
my
received
question.
any message, I just skip. I don't know. I don't do anything because
Right.
right now, I don't have any feedback. I shouldn't do
Great check
anything.
there.
So that's why I add this one. So scan received. So beside we look at the front, also we look at on the right side. Look at on the right side, so you can see we look at index from 0 to 360, from way straight back to straight right to straight front. Look at the right side, and also begin with I give a shortest a large number, and whenever we see a shorter one, a smaller one, and I update it. So when I go through, we get two result variables. One is the shortest, which is we give to the variable right, which is
Mm-hmm.
shortest distance to the right, and also the shortest index, which we're going to use those two variables later. So that's for the scan callback. And so that's when the main process is drive one step. So this is you've seen earlier, this happened every 0.1 second. So when we come here, I set the linear speed constant always, basically never change. So what we change is angular speed.
Mm-hmm.
So angular speed, if everything good, angular speed is 0, we not turn anywhere. But anything happen here in all those conditions, we will turn. When this is when the distance to the right is too short, less than 0.2, it will turn left. And when the distance is too far, larger than 0.3, it will turn right. And here, here is a little bit tricky. I want to also control the orientation of the robot. So if the shortest index is larger than 200, which is we kind of
It's
toward
too
a
much to the
little bit
left.
to the right, to the right
Oh yeah, to
direction, which is we kind of running towards war kind of. So
uh-huh.
we make a left turn here. And the same thing, if it's we see ourselves orientations running away from war, we turn it back, make a right turn.
Makes
So
sense.
that's what adjust the direction of robot. Other than that, and it will keep constant no turn. And once we reach another war, so which is when the friend is less than 0.5, and this will overrule everything above, we will turn. So because we hitting another war, so we make a left turn as fast as possible to make a left turn. So that's what it is. So that's and also at the end, that's a kind of I give another quick method. It just stop the robot. So that's we can use it at the end.
Great.
Okay, so if it's no other questions, so that's the follow the wall process. And the other two are just the other two client we can talk, but I think that's nothing fancy. So I think we should more. I think we're going to spend more time on the server side. So on the client side, for example, this find wall client. So which is we just wait for the surface. This is kind of routine. Wait for the surface, and create a surface client, and also create a surface object, and then call from the client, call the surface
This is
and
great.
wait. Yeah, wait. This is kind of very basic, and wait for finish. Once it's finished, we send a response, or if it's error, we export error. So that's very basic kind of client.
Mm-hmm.
Similarly, for the client of the action, it's again, I think it's still kind of basic one. So I can hear for the action still we we wait for the we create a action client here in the class, and also we have another variable action done. As so you remember, the main service waiting for this. When the action is done, when this becomes true, we'll stop everything. So this is I just create another boolean here, and so we again, this is client. We wait for server. When the client when we start a client, we wait for server surface action server, and then we create a goal. And I think as remember, there's no really the goal here. It's I think as I remember, it's kind of empty, so we don't have to put anything inside
Oh,
the goal.
okay.
We just call it.
You just call it. Yeah.
Yeah, we just call it, and there's a few callback. There's when everything finished, we could have done callback, which is when the when it's done. and also have active callback and feedback callback. Active callback when it started, and feedback callback is happening all the time during the process.
Mm-hmm.
So when this done callback, when everything finished, we just show everything, especially the list of autumn, which is the kind of response from server,
Yeah.
tell us, okay, when we are done, all the point we have been through, and it recorded and put into this list, and I show the list here when everything's done. So that's pretty much for the done callback. And besides, also action done is put back to true in the as a Boolean variable set to true. So that's for the done callback. For the active callback, it's just when they started, just show, hey, we started. And feedback callbacks also pretty much just show, hey, I mean, as you remember, just I can show you quickly the odometry action definition is like this. So we don't have anything in the pretty much nothing in the goal. And the result is the list for autumn. The feedback is current total, which is
Right.
how far have been run, and that's what the total. So what I do here is I just show the number on the screen. So hey, how far we have been running
Great.
so far. So
10 more minutes then.
oh, okay. Oh yeah, 10 more minutes. Okay. Okay, I try to be quick. All right, so let me do a little bit faster. Let me get this autumn record action server. Let's get it done quickly, and then we go to the find word surface server. So this is our autumn record server, autumn record action server. So again, a bunch of variables,
Is,
and
is it just the server? The
yeah,
node is just has the server with its server callback. Is there anything else in there?
with the server callback. So it just we just define the callback. For example,
Ah,
the
yeah.
yeah, once the this sub callback is when it
Every time you
the
receive a new odometry point, right?
yes, exactly. So once I receive new odometry, I update this current point
It
x,
gets
y, and
triggered.
z. So this z is I did a little bit math to calculate orientation angle of the rod. I put it here z,
Okay.
and execute callback. This is a main. So this is a little bit let me go through this quickly, hopefully. So this is execute main. This is a server. So once the client call server, this is what happens. So first of all, it will check if someone stopped the ROS, and also we talk about these two conditions a little bit, and so we talk here. If we receive very first point, so very first point, we start from origin. Once we receive very first point, we we set this point as original point, copied them, and also we put them as a last point because we're going to calculate every step from the last step. So this is, I have the original point, I have last point, and then we calculate the distance from current point to the last point. So the distance here, and after calculation, also I update last point to the current point. So it just we step by step. So also we calculate this distance to the origin point, and then here is kind of a little bit trick here is once I left origin to some distance, left origin distance, this is I kind of define like a magic number like 0.5. If I run far enough, I say, hey, I have left origin. So once I come back, then I'm back. That's the end. So that's I kind of give this kind. So that's a we check. Okay, have we left origin yet? So that's one of condition. The other one is, have we coming back yet? So this is we also checked here. Actually, it's just here. So distance to origin. Once we check distance from origin, once we have left origin, right, we have a run far enough sometimes, and then we come back. If the distance is shorter than this one, I put at 0.2. And once we have left origin, once we come back, we get out of this while loop. Otherwise, we stay here, keep running. So that's a kind of condition here. And then after update everything, we calculate the total distance. We add the last distance, which is distance from last point, last distance, and we add to the total distance. We publish this as a feedback to the client. So that's basically the autumn record action
All right.
server.
Very straightforward. Nice.
Thank you. Now let's come back to this follow war action. Follow war. I'm sorry.
Service.
Yeah, service. Where is it? Give me a second. For find war. Put it follow war. I'm sorry. Oh, here. Okay, so front here. Let me go to. This is one. This is a find war surface server. So this is a little bit. This is the most complicated. Hopefully, we don't run over time too much. So
don't worry about
for this find war surface server, because this is kind of 3 steps. First step, find nearest war. Second step, run to the war. And last step is make a left turn. So the second, third step are relatively simple. The first one is most complicated. The reason is we had to, because there's object in the middle of the ground. So we had to identify that object. That's not war, and we should not run towards that. So that's make things a little bit complicated here. So that's make the first step a little bit complicated. So that's again, I claim 2 vector, basically kind of array vector here, and which is a 720, which is again we record the distance 360 degree all around Robert, and section which is the integral. I will explain to you in a minute. So after that, just node handle, drive the Robert, subscribe to the scan result, and similar like last time we record the shortest and the index to the shortest. And also we provide the surface. And the scan callback, which is once we receive the scan message, and scan callback, you see nothing. We just update the class variable from the message to update the value. That's it. And also scan receive, similar to last before. If I haven't received anything, I will not do anything. So that's, I have another boolean here. Okay, so before we talk about final war, I have another 2 kind of subroutine to explain. One is find the shortest. Find the shortest is we give a start index and end index, and this piece of thought we will go through the the ranges. We just the scan result ranges from start to the end, and find the shortest. So and once it's once it's done, what we want is we want to see the shortest and indexed used. So all
right.
So yeah, so the only a little bit complicated here is because 320 is the same as 0. So we allow go like from 310 to 10. So that's a make
like so only the back part, very back, is not being taken into account.
We take it into account, but it just I'm saying that's what makes this a little bit complicated. Like for example, if the end is less than 0 added, or so that make, but we do take into account everywhere. So that's what I will say here. I just I guess we don't have time, so I will not go to too much detail. That's why I'm just saying this is just what make it a little bit complicated. But it is, again, the idea is straightforward. So we just go from one index to another index, find the shortest distance between. So that's it. And also another piece I want to explain is the check object. This is really the key to identify the object. So check object, again, so right now we assume we have a 360 degree, which is 0 to 220 ranges numbers. So I have another vector or array defined, and what I do is I locate two array numbers next to each other and look at their difference.
Mm-hmm.
If their difference is bigger than 0.1, and I see, oh, that's an object to a wall or object to another object. Because if I scan around the wall, the ranges number should not change much, should be continuous. So once we see discontinuity there, I see, oh, that's this point is the boundary between object and wall.
Mm-hmm.
So then when that start, I start the section number as a 1, and when I keep going, I add this section number from 1 to 2 to 3 to until the next boundary, jump back to 1 again. So and also here a little bit complicated again is try to take care of the back things. So make it a sequence around.
Make it all around. Yeah.
Yeah, go around. So once this piece of software done, besides the ranges, we have another vector or array, get a number from 0 to some number and from 1 to some number again. So that's what the way I didn't identify object from the wall. So that's first one, we get each section from 1 to some number. And secondly, let me at the end, what I want to do is I want to give all the object a super large distance. So you can see here, I see, okay, if your section number, again, this is kind of magic number 100. Why put 100 in here? I think most the object here so far, I see there's no more than 100 in the range, in the angle. So if anything less than 100, I say, hey, you are not war, you're object. And if you're not object, I force your ranges. I force give you a large number. So when I look for the shortest distance, I will ignore you. So
yeah.
I do here. So that's another thing. The last part I want to explain is that's another trick is even the war, the index number will go from 1 to 100 to 101 to a number. So here I just take care, if this section is more than 100, I update index number, which is smaller than 100 to more than 100. I don't know if I...
Yeah, I understand you perfectly. Here. So
yeah, so by doing that, the war will not go from 100 to some number anymore. It will go from 101 to some number. So from here, I can guarantee the war, the index for war sections always larger than 100. So why do this part to kind of keep, to identify the object, the war will not be affected. So I just, that's the most difficult part so far, I hope. And from there, that's just simple. So, I mean, you can see the main callback for the surface is 3 pieces. It's, it wait for get some receive, aim the war, go to war, and left turns. So aim the war, it's here, and it will check object, which is get rid of all the the object and leave only war there, and then we find the shortest, and we through the whole range, and we get the shortest, and we make a turn here toward the shortest, and every step until the shortest index is 360, which is we are facing that direction. And then the next part is go to the war. So this is really simple. We just only look at this narrow in front of the robot, and we look at the distance when until the distance is less than 0.3. Otherwise, we just keep moving forward. That's it. As we get there, we stop. Same last thing is the left turn. Left turn is we keep turning to the left. Linear speed is 0, angular speed is 0.2. And keep left turn until the index, which is 180, which is on the right side of the robot. Then we stop. So otherwise we keep moving. Once we get there, we stop. So that's basically this. Did I run over time?
A little bit, but don't worry, don't
Okay.
worry.
Okay.
So
Yep.
great, this is amazing. Let me ask you to stop sharing your screen so we can see our.
Okay. And you want me to stop sharing?
Yes, please.
Okay. Yeah. Okay.
All right, awesome. So we can see our faces here
Okay.
in the stream. Great job, great job.
Thank you.
I see that you went even further than the last project you were working on. So
Yeah.
congratulations on that. I really liked. First, I'll tell you what I liked and why. So I really
Okay.
like that you have header files in libraries because
Okay. Sure.
the main. So we're doing ROS Basics in 5 days. So it's the first step. So a lot of people that I don't know about you yourself, but you seem like you're pretty experienced with code. But a lot of people don't really know a lot
Yeah.
of
Some experience. Yep.
C++ or Python, right? So
Yeah.
um, that leads to people to, for example, in this case, they want to do everything in one file, right?
Oh yeah.
Because it keep so this shows perfectly why you shouldn't, why you should
Yeah.
do this because it's just so simple to keep track of things and
Um,
just it runs more efficiently. So that's something I really liked. So
sure.
another thing is that that distinction that you went to differentiate between an obstacle and the wall. And
Okay.
let me tell you why. That that right there, what you have there with the I call them big reading jumps. What you were saying about the difference between one scan value and the next. If it's greater than blah, then
Mhm.
do something with that. So that's, for example, that can be a basis to identify objects, not differentiate things. But let's say
Mhm.
you have a charger that you want to approach.
Oh yeah.
Well, you can do exactly this logic because then you can control, for example, if I have my, I forget what you call it, but I call it like that. If there's a big difference, then that means
Yeah.
that's not the wall anymore, it's something else. And then you can
Yeah.
start measuring, like, let's say, and then you keep going until there's the next big reading jump.
Yeah.
Uh,
Yeah.
and then you check how long that is and then basically say, I have something that's 40 centimeters in my environment. The only thing that's 40 centimeters is the charger. So
Yeah. Yeah.
now I can see the charger. So that's great for you to, keep building on it. And just by adding this little extra step of differentiating obstacles from the wall, you can extrapolate that to do so many more applications with just a
Yeah.
laser, which is great. So I wanted to make sure I said that
Okay.
for
Yep.
your
That's
work.
right.
So great job. And then, I mean, just one suggestion that I saw that it's not even a
Sure.
big deal,
Sure.
but you talked about the magic numbers a lot,
Yeah.
which are constants
Yeah.
basically, right? You
Yeah.
just put
Yeah.
them in and
Yeah.
you just use that. And another example, for your recognizing the front of the robot, you put 180, the back is 360. Just my suggestion is to make those, I call them hard-coded numbers, into
Yeah.
variables, right?
Sure. Yeah. Yeah.
Because that helps you for your or for my mind at least for organizing
Yeah.
it in my mind is a lot easier, and you can do things. For example, you don't have to worry about how big the laser scan is. How many values it has. If most of
Mhm.
them, which they do, but if they don't, you find out pretty quickly that they start at the back, and then you can just say the length of the whole range of lasers
Yeah.
divided over 2, that's my front laser. So you wouldn't have to care if
Yeah.
it's 720, 360, 1 million. Of course, that
Yeah.
changes when you don't have a field of vision, which is 360 degrees, which happens in a lot of lasers, right? But
Mhm.
but the idea is that you make it as general as possible. So when that scenario arrives,
Mhm.
let's say you have a different
I see.
laser or whatever, you don't have to spend 3 hours redoing that.
Exactly. Yeah.
You can just change a couple of
Change
constants,
and
and then move forward with it. And
sure, yeah,
this is what I
that's the,
found that
sure,
is one of the biggest, how should I call them, like choke points
yeah,
in when starting to program. When I
yeah.
started programming, for example. So other than that, I loved it. Very clear, very
Thank you.
simple, and putting on top of what you did last project. So congratulations, Lou. I really liked your project.
Sure, thank you, Rob.
And I guess just one more question for you. Now that you've done both the Python and the C++, can you think of other applications where you could use a service server and an action server for something like this with a differential drive robot? Something that comes to mind that you are thinking, oh, this could be really useful. Now I can apply an action for this or for that. Is there anything that pops in your head?
Um, again, again, I mean, I can be direct. I what I work is kind of related to the robotics.
Mm-hmm.
So we use quite in some cases. So again, I mean, for me, I like to start from simple. So everything start from like ROS messages.
Mm-hmm.
But the benefit of giving the feedback and also for the service, and also have something run in parallel for the action, so which is really useful. So for example, if have one robot have some other again have any other things need to be uh, provided by the robot. For example, I don't know, like a robot, when the robot run, we have like some LED, some light want to turn on for some time, or so that can be done in the can be done probably in the surface,
Yeah.
because we
Yeah.
can ask, hey, can you turn on the light, and be the benefit from the message is we can give feedback. You say, hey, okay, I can turn on the light, I turn it on, and you know the operator know, okay, you get it, you turn it on, you give me the feedback, that's great. So
Yeah.
that's kind of a benefit with all with all the
Right.
surface and
And you can take
action.
different actions. I don't want to say actions, different things based on the
Mhm.
feedback of an action server. For example, in that example, you identify the charger that you have to go to. And then you're
Oh
like,
yeah.
all right, let's go to the charger. But you have to keep track of things like, I don't know, the center of the charger or the odometry or whether it's going straight. And you can have those in the feedback and take actions based
Yeah.
on what happens. For example, something happens and your charger gets moved or something, and one of those things change. Then you can use that feedback to say, "Oh no, let's restart it, or let's do something else." Blah blah blah. So, um,
And when it failed, when it's stuck somewhere, also
exactly
we kind of know, because you
right,
keep
and
giving me feedback, so what's going on, what happened.
you
So
don't have
it's
to wait until the service server says like, "Oh, it failed," and you're like, "Well, that sucks because now my robot exploded or something like that."
yeah.
All right. Well, awesome, Lou. I'm really happy about your presentation. And for everyone else that's listening, I do this every time, but I'll do it again. This is your chance to do something like this to prove of all of the learnings that you do in our course. And please tell us what you think when you do them, and come here to present like Lou did. Thank you very much for watching. Thank you very much, Lou, and I hope to see you soon.
Sure, thank you, Bill.
All right, guys. See you later, everyone. We'll be back here at Becoming a ROS Developer soon. Bye bye. All right.